students, myself Jambagi, welcoming you all for 9th standard online classes in our YouTube channel. Dear students, in the previous period we have discussed the acceleration part, deceleration, as well as uniformly accelerated and non-uniformly accelerated motions. Hello, we have begun with some problems. In today's lecture, we are continuing the same concept of problems. So, the first problem, that is on acceleration. Starting from rest, an object moves with a velocity of 25 meter per second in 5 minutes. Find the acceleration of the object. So, the first point, starting from rest, assume this is the body which is moving with some velocity, that is in that case is 25 meter per second, and time will be 5 minutes. So object starts moving from rest means, according to the given data, initial velocity u is taken as 0. It is starting from rest. Okay. Now the final velocity will be that is v, which is equal to 25 meter per second. Okay. Now time is also given, that is time t is equal to 5 minutes. So better it is converted into second. So 5 minute means 5 into 60 second, therefore 300 second. Okay. Then what is the question? Acceleration of the object is equal to how much? Acceleration A is equal to how much? This is the way we are analyzing the problem systematically. Initial velocity is taken as 0, final velocity is 25 meter per second, time t is 5 minutes, which is equal to 300 seconds. Acceleration is equal to how much? Let us solve that solution. By the definition, we already know that by the definition you call acceleration A is equal to v minus u divided by t, that is change in velocity of the object divided by time taken by that object, that is equal to this much. A equals to v minus u by t. Now bring the values here into the formula. Therefore acceleration A is equal to v is 25 meter per second, you take it 25, minus initial velocity is 0 meter per second, therefore 25 minus 0, combine the, that is meter per second, divided by time is 300 second, we took that 300 second. Therefore acceleration A is equal to 25 divided by 300 meter per second into second. Therefore A is equal to 25 by 300 meter per second square. This is the acceleration of the body. So this will be the first problem. I hope you understood this problem right. Second problem. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds of time, a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds of time. Find the acceleration of the bus. What will be the acceleration of the bus at that period? Okay, so here the speed is in kilometer per hour. You take it in terms of meter per second, or you just convert second in terms of, so whichever method suits you, follow that. Okay, so it's better to convert kilometer per hour into meter per second, and we'll write the acceleration in meter per second square only. Okay, now given data, a bus decreases its speed from 80 km per hour means initial velocity of the bus, that is u equal to 80 km per hour. So 80 km per hour can be written as 80 into 1000, that is meter, divided by hour means 3600 second. So these zeros cancel each other. You left out with 80 into 10, that is 800, divided by 36 meter per second. That will be the initial velocity of the bus. Then v, the final velocity, that is v equal to 60 kilometer per hour, and hence 60 into 1000 meter divided by 3600 second. Therefore, again these zeros cancel each other. 600 divided by 36 meter per second. So this will be the final velocity of the bus. If you solve this 800 by 36, you will have to put 22.2 meter per second. On the other hand, 600 by 36, that is 16.6 meter per second. Now time is given, time, that is t equal to 5 seconds. Therefore, acceleration of the bus is equal to how much? Acceleration of the bus A is equal to how much? We have the formula again for acceleration. A is equal to v minus u divided by t, which is equal to 22.2 meter per second minus 16.6 meter per second. You take it meter per second common, divided by 5 seconds. Therefore, acceleration A equals to 22.2 minus 16.6 means, that is 5.6 divided by 5 meter per second square. Therefore, acceleration A equal to it is A equals to 1.12 meter per second square. This is the acceleration of the bus with respect to the change in velocity given in the problem. I hope you followed all these steps correctly. Next problem. A body has the acceleration of 2 meter per second square. A body has the acceleration of 2 meter per second square and the final velocity of 4 meter per second. The final velocity of 4 meter per second. Then find the time. So till the two problems we talk of acceleration only. Here in this problem we have acceleration and the final velocity given. Therefore, you are asked to calculate what will be the time taken by the body. Okay. Now, given data from the problem is as follows. Acceleration A is equal to acceleration A equal to, that is 2 meter per second square. Then the final velocity that is given here, final velocity V is equal to 4 meter per second square, and here initial velocity will be 0 because of our understanding only final velocity is given. They did not bother about initial velocity. We are assuming that initial velocity should be equal to 0. Okay, that is by understanding we are taking it, and hence I am giving the reason here taken from our understandings. I hope you are getting these things right. Okay, then what exactly the parameter is asked, that is time. T is equal to how much, and we are already know the formula for acceleration, that is A is equal to V minus U divided by T. We want T, just rearrange the terms here. By cross multiplication we have A on this side, T on this side, therefore send T on this side or interchange those, therefore T is equal to V minus U divided by A. Therefore V is given 4 meter per second square minus 0, that is initial velocity taken, that is in terms of meter per second square, meter per second, divided by acceleration, that is how much, 2 meter per second square. Therefore you will have out with 4 divided by 2 meter per second. It can be written like this, meter per second or ms to the power minus 1, both are same. Okay, then meter per second square is also here, therefore sending s on the above or numerator divided by meter, therefore meter get cancelled, s and one of the s left out, therefore 4 by 2 is 2 second, and hence time t is equal to 2 second. So this is the third problem. Alright, we are moving to the next problem, that is the final problem of this session. Starting from a stationary position, starting from rest position, Rahul pedals his bicycle to attain the velocity of 6 meter per second in 30 seconds. In 30 seconds, Rahul pedals the bicycle, by that it gains the velocity of 6 meter per second. Then he applied brake. Such that the velocity of the bicycle comes down to 4 meter per second. So after applying the brakes, he got the velocity, that is of 4 meter per second in 5 seconds. In next 5 seconds after application of the brake, after 5 seconds he got the acceleration, he got the velocity of 4 meter per second. Then calculate the acceleration in both the cases. In two different cases in this problem, we are going to solve the accelerations. So I am taking first case and second case. So let's try to get the first part or first case. So starting from stationary position, Rahul pedals his bicycle to attain the velocity of 6 meter per second. From rest state or from stationary position, initially they said he starts his journey from stationary position, which means initial velocity will be u is equal to 0 meter per second. Then final velocity during that course, that is v equal to 6 meter per second, and time is also mentioned. Time t is equal to 30 seconds. Therefore, acceleration in first case, I am taking acceleration here a1. A1 indicates the acceleration in the first case is equal to how much? Again, the same formula is applicable. Solution for the first case, acceleration a1 is equal to v minus u divided by t, which is equal to v is 6 meter per second minus 0, combine the meter per second divided by 30 seconds. Therefore, a1, the acceleration in first case, that is 6 by 30, which is equal to 1 by 5, that much meter per second square, or else acceleration a1, which is equal to 0.2 meter per second square. 0.2 meter per second square will be the acceleration of Rahul, who was paddling his bicycle. Okay. In the second case, initial velocity, here it is going to change. Initial velocity is 6 meter per second. Before application of the brakes, he maintained 6 meter per second, that much of velocity. Therefore, in this case, in the second case, I mean, initial velocity u is equal to 6 meter per second, that is by our understanding. Then what will be the final velocity? Here the final velocity will be v equal to 4 meter per second after the application of the brakes. After the application of the brakes, we have 4 meter per second, and hence final velocity will be 4 meter per second. Then the time is mentioned here also, that is next 5 seconds they have mentioned, that is 5 seconds, and hence acceleration a2 this time. In the second case, a2, the acceleration 2, or in the second case, which is equal to how much? Again, you do the same, that is here a2 is equal to v minus u divided by t. So v is this time 4 meter per second minus 6 meter per second. So you take it meter per second common, divided by 5 seconds, and hence a2 is equal to minus 2 divided by 5 meter per second square. So you got the acceleration in the second case, that is minus 2 by 5. Minus 2 by 5 is equal to minus 0.4. Minus 0.4 meter per second square. And hence acceleration after the application of brakes, you got minus 0.4 meter per second square. We have the negative sign. As I mentioned, acceleration is a vector quantity. It can be negative. Okay. If the negative value arises in such cases, please don't panic, since the vector quantity and the vector laws obeying that. Therefore, I am saying that negative can be done. Okay. This ends today's lecture. With some more videos, I will meet you in the next week. Till then, take care of yourselves. Bye bye.